What's up, team? Today we're talking about the area and circumference of a circle. So down below it says, I can find the area and circumference of a circle. This video is mostly going to be discussing how to find the area of a circle, like where that formula comes from. So let's start with defining what a circumference is. A circumference is the length of the border of the circle. Think of like a rectangle where you find the perimeter. The circumference is just what we call the distance all the way around the outside of a circle. So if you have a circular shaped field with a fence around it, the length of the fence is the circumference of the circle. The way that we find that, the circumference of a circle can be found by doing 2 times pi times r, or the circumference is pi times your diameter. And of course, r here is your radius. So if we're looking at a circle, we know that the diameter is this line that goes all the way across and also through the center. A radius is exactly half that. It's the distance from the center of the circle to one of the sides. So for example, if the diameter of this particular circle is 10, we know that the circumference of this thing, following our formula, is 10 pi. And pi, you can either leave your result like this or do a decimal approximation. Pi equals approximately 3.14, so our circumference then is approximately 31.4. No, just units. It's a distance, not units squared in this case. Let's say that you're given, instead of this stuff, say you don't have the diameter, say that you have the radius, and the radius is 6. So that means this piece here is 6. Well, you could infer that the other radius, the other side, is also 6. So you have a diameter of 12. You can also just use this 2 pi r formula. So circumference equals 2 times pi times r, which is our radius, which is 12 pi. And again, you can just type that in your calculator, 12 times pi, and get a decimal approximation if you choose. Both responses both work for me for this particular course. So where does this pi come from? Pi is not it's not like a made-up value. I know you've seen it before, 3.14159. People quote it and memorize certain distances of it, a certain number of decimals and stuff. That's all good and fine. But pi was a value that was discovered by some folks, again, that shared it with the rest of us and gave us a big giant shortcut. Basically, what they discovered with any circle ever, if you know the diameter of that particular circle, the ratio between the diameter and the circumference is pi. So if you have the diameter, you multiply it times pi, and you're going to have the circumference of that circle. That's true for any circle, whether it's a Ferris wheel or the tires on your car, an Oreo, just whatever. If you have the diameter, you just multiply that times pi, and you will have the length of the circumference. So it's pretty powerful, Okay, we are going to use the idea of circumference to derive an area formula together. And the way that we're going to do that is we're going to create a whole bunch of triangles inside of our circle. So it might look like this. To make it look kind of like a wheel with some spokes. Now, if I was a computer, I would make infinitely many tiny triangles. But for now, I think you get the picture. And we could take these as if they were slices of pizza, and we could stack them and create a parallelogram, kind of like this. So say that one of our triangles fits here, another one is here, and we just stack them so that they form this parallelogram. Something like, not perfect, but you see what's happening here. So I took a slice, I put it here. I took the slice next to it, and I put it here, and I've rearranged it in such a way where we've created a parallelogram. Now, maybe you don't see where I'm going with this. That's okay. Just stick with me. But I'm hopeful that you agree that the area of a parallelogram can be found by doing base times height. Base times height. This is something we've studied recently. So I want to find the area of this parallelogram because we've taken the entirety of this circle. Again, remember, these are stand-ins for infinitely small slices of our circle, pizza slices of our circle, and we've just taken them away and we've rearranged them to a shape that we know how to find the area of. So we're going to find the area of this parallelogram, and we're going to make a formula involving radius and stuff like this, which is going to be our area formula. So if area is base times height, we need to figure out, well, how can we understand what the base of this parallelogram is as it relates to our circle? Well, we took these tiny pizza slices of our circle and put it into a parallelogram, And so all of these on the edge here, all of these pieces came from the edge of our circle. And half of them are on the bottom and half of them ended up on the top. So the base of this thing, the distance for the base, is just half of the circumference, because we took half of these and are on the top and the other half are on the bottom. So the base is half of what the circumference of whatever circle we're working with. We're just talking in general terms here. So just any circle ever. And the height of this parallelogram again, well, is going to be something like, I mean, we could do it anywhere, just some right angle that connects the two opposite sides here. And, well, I think it's going to be the radius of the circle, because it's the distance from the center, because that's where the kind of the pointy part of our pizza slice is right here at the center, and going straight out to the side of the circle. This is going to have length r, because it's the distance from the center to the circle. And it can be anywhere, because all of the distances from the center to the side of the circle is r. So the height of this thing is just r. Interesting. So the area then can be found, the area of a circle, by doing 1/2 times the circumference times r. Well, we can clean that up even a little bit further. The 1/2 is still there, but we can talk about the circumference in terms of r or in terms of the diameter here. I'm going to talk about it in terms of r. So I'm going to replace my c, or substitute a value in for c, the 2 pi r. 2 times pi times r. And then we still have this other r from our previous step. So we have a couple different r's there. And we can, just our last piece of the puzzle here, we can simplify. 1/2 times 2, and that's just 1. Pi is going to be pi. And then r times r is r squared. So to find the area of a circle, we use this formula, pi r squared. And I imagine you've seen this before. This might not be new. But my hope is that you now see kind of where it came from. If we take all these slices, these pizza slices out of any circle ever, and they're infinitely small, they're tiny, tiny, tiny slices, we turn them into a parallelogram, and we can use tools that we already have to derive this formula. Again, someone much wiser than us, years and years ago, centuries ago, came up with this idea, and it's just absolutely brilliant. Super cool stuff. Okay, I'm going to pause this thing, and we're going to do just a couple quick examples, and we'll wrap it up. Okay, here's 2 quick examples. We have this circle here. We're given a diameter of 11 centimeters. To find the circumference, we're just going to use our 2 times pi times r, or our pi times d. We have the diameter, so let's just use that. We know it's going to be 11 times pi centimeters. Boom, there it is. We could also type in 11 times pi into our calculator to get a decimal approximation, and we learned that this is approximately 34.56 centimeters. Either of these responses are equally as correct. They'll both get you the same amount of credit on any practice problems or any quiz or anything. This is more precise, but this one is a little bit easier to wrap our minds around. So they both work for me. Okay, the area. It's 2 times pi r squared. So it's going to be pi times our radius. Well, the radius is half the diameter, so it's going to be 5.5 squared. So on my calculator here, I'm going to type in 5.5, and I'm going to square it, and I learned that that is 30.25. So 30.25 pi centimeters squared is a fair response. This could be done. This is a precise response. Or it's approximately that stuff times pi, which is approximately 95.03 centimeters squared. Again, 2 equally valid responses. This one's more precise with the pi. This one we had to do some rounding, but it's easier to wrap our minds around than 95. Okay, same thing, but a little bit different. This one we're given a radius. The circumference here, I'm going to do 2 times pi times r. And our r, is, of course, is 2. So the response here is just 4 pi miles. And we could throw that in a calculator. I'm not going to take the time right now. Next one, the area of this is pi times r squared. So that's 2 squared. So again, this is also 4 pi miles squared. This is a unique situation where the circumference and the area both have the same response, 4 pi as your response. It's the only size circle ever with a radius of 2. It doesn't matter what the units are. It could be miles, feet, inches, centimeters, whatever. But the only circle ever that your that your area and your circumference are going to end up having the same value. So it's a super unique case. It's a lot of fun. There's a question about that in your practice problems, actually. So if you're watching this video, lucky you. Okay, your practice problems are going to be a little bit trickier than what you see here. You're going to have to locate whatever the diameter is or whatever the radius is. It's not going to be just handed to you. So it's going to be a practice in solving puzzles, finding the missing pieces, and then plugging them into the formula. The formulas are the easy parts. Okay, go ahead and check that out. Let me know if you have questions. You got this.